Dear students, welcome to my next lecture on physics for class 11. In today's lecture, we will answer some of the questions in the form of exercises. As you know, this lecture is concerned with units and measurements, which is given as chapter number 2 in your textbook. So, all the questions are important and explanation is given in the form of answers. Please open your notebook and pen and note down all the important points. Welcome you once again. So the first part is in the form of questions which are valued for either 1 or 2 marks. Question number 1. A new unit of length is chosen such that the speed of light in vacuum is unity. What is the distance between the sun and the earth in terms of new unit if light takes 8 minutes and 20 seconds to cover this distance? So you please read the question once again and I will give the answer. It is given speed of light in vacuum c is equal to 1 new unit of length per second. So speed is in unit of length per second. So new unit is equal to c is equal to 1 new unit of length per second. Therefore, it is given that t is equal to 8 minutes and 20 seconds. That is converting 8 minutes into seconds. That is 8 into 60 plus 20 seconds. That is equal to 500 seconds. So therefore, x is equal to c into t. That is distance is equal to speed of light into t. Here c is the 1 unit of length per second into t is 500 seconds we have calculated in the previous step. That is equal to x is equal to 500 new units of length. That is the answer. Next question. If x is equal to a plus bt plus ct square, where x is in meters and t is in seconds, what is the unit of c? So we have to find the unit of c. Answer. The unit of left hand side is in meters. That is x is in meters. It is given in the question. So the units of ct square, that is the third term on the right hand side, should also be the meter. That is the answer. Since t square has unit of s square, so the unit of c is meters per second square. Question number 3. What is the difference between small m capital N, comma, capital N small m and small n and small m? So we have to tell the difference between these three terms. Small m capital N means millinewton. So N stands for Newton and small m stands for milli. So 1 millinewton is equal to, milli means 10 to the power of minus 3. That is 1 small m capital N is equal to 10 to the power of minus 3 newtons. Capital N small m means capital N stands for Newton and small m means meter. So in the previous case, small m coming before n is milli. Here after n means it is Newton meter. So small m means nanometer. Here small n stands for nano. Nano means 10 to the power of minus 9. Question number 4. The radius of atom is of the order of 1 Armstrong unit and radius of nucleus is of the order of Fermi. How many magnitudes higher is the volume of atom as compared to the volume of nucleus? So he has used different terms for measuring the radius. Radius of atom is measured in Armstrong unit and radius of nucleus is given in Fermi, which are two different names. So we have to find how many magnitudes higher is the volume of atom. So question asked is, please note volume of atom as compared to the volume of the nucleus. So radius is given for both and we have to find the volume of the nucleus. So answer is volume of atom over volume of nucleus is equal to, we know volume is 4 pi r cube. So 4 pi into atoms is Armstrong. Armstrong is 10 to the power of minus 10 whole cube. R cube is 10 to the power of minus 10 whole cube. Divided by nucleus is in Fermi. 1 Fermi is 10 to the power of minus 15. That is equal to 15. So the denominator is 4 pi into 10 to the power of minus 15 whole cube. That is equal to, see, if you substitute, if you simplify, so it gets 10 to the power of minus 10 gets cancelled with the 10 to the power of minus 15 in the denominator. Taking whole cube, it becomes 10 to the power of minus 15. That is the answer. How many kg make one unified atomic mass unit? So answer is 1 atomic mass unit written as 1 U is equal to 1.66 into 10 to the power of minus 27 kg. This you have to remember. You can remember if you practice it repeatedly. Question number 6. Name the 3 physical quantities that have the same dimensions. Answer is work, energy and torque are 3 different physical quantities, but they have the same dimensions. Question number 7. Name the physical quantities that have dimensional formula within brackets, big bracket, capital M, L to the power of minus 1 and T to the power of minus 2, capital T to the power of minus 2. Answer. Stress, pressure and modulus of elasticity have the same dimensions. This is also given in your chapter number 2 in the table. Stress, pressure and modulus of elasticity. You please go back to my lecture of chapter number 2 and remember that stress, pressure and modulus of elasticity have the same unit, same dimensional formula. Question number 8. Give 2 examples of dimensionless variables. So the dimensionless variables are strain and refractive index. That is the answer. Question number 9. State the number of significant figures in the following cases. Case number 1 is 0.007 meter square. Case number 2 is 2.64 into 10 to the power of 24 kg. And case number 3 is 0.2370 grams per centimeter cube. Case number 4 is 0.2300 meters. Case number 4 is 4.330 and case number 6 is 86400. So these are 6 different numbers and we have to state the significant figures in each of these cases. Let us answer it. Answer. In question number 1, the number of significant figure is 1 because there is only one number after the fraction. This is the most significant figure. And here in case number 2, there are 3 digits, 2.643. So most significant figure is 3. And in third case, significant figure is 4. That is, after the digit 2370, there are 4 digits. So significant figure is 4. In case number 4, after the decimal point, there are 4 figures. So we have to, there are 4. It is 4. That is 2300. In the fifth case, it is 4.330. That is, before the decimal point, there is 1. So we have to count all the numbers here. That is, 4 is 1, 2, 3, 4. So in case 5 also, the answer is 5. In case number 6, there are 1, 2, 3, 4, 5 digits. Hence, it is 5. Since it comes from measurement, the last 2 zeros become significant. Question number 10. Given relative error in measurement of length is 0.02. What is the percentage error? Answer. 2%. That is, you have to simply multiply the given number, that is 0.02 into 100. That becomes 2%. Next question. A physical quantity P is related to 4 observables A, B, C and D as follows. That is, P is equal to A cube into B square divided by D into square root of C. The percentage error of measurement in A, B, and C and D are 1%, 3%, 4% and 2% respectively. What is the percentage error in the quantity P? So, percentage error for each observable is given and we have to find the percentage error of the resultant P. Therefore, relative error in P is given by delta P over P equals A cube. A cube means it is 3 into delta A by A plus B square. B square means 2 into delta B by B plus D percentage error in D is D delta D by D, and percentage error of square root of C is half of delta C by C, because C is C to the power of square root of C is equal to C to the power of half. Therefore, error is half of delta C by C. Now we have to simply substitute the given values. Delta A by A is given as 3%. So 3 into delta A by A into 100 we have to substitute. Let us substitute the values. That is 3 into 1% plus 2 into 3% and 1 into 2% plus half into 4%. That is, C is 4%, so we have taken it 4%. Combining, we get 13%. That is the answer. Question number 12. A boy recalls the relations for relativistic mass m in terms of rest mass m0, velocity of the particle v, but forgets to put the constant c, velocity of light. He writes m is equal to m naught over 1 minus v square to the power of half. Correct the equation by putting the missing c. That means he writes the equation for mass in terms of rest mass and velocity, but he forgets to put the constant c. He writes m is equal to m naught over 1 minus v square whole to the power of half. Correct the equation by putting the missing C. Answer. Since the quantities of similar nature can only be added and subtracted, V square cannot be subtracted. Here in the numerator cannot be subtracted from 1. But V square by C square can be subtracted from 1. Therefore, the given equation, the correct equation is M is equal to M naught over 1 minus V square by C square into the power of half. The boy has forgotten to write after the negative sign V square by C square. So it is correct is he has to write V square by C square. Question number 13. Name the technique used in locating an underwater obstacle and B, position of an aeroplane. So first part A is underwater, part B is in the space. Object is in space. Answer. Part A. For underwater, we use sonar, that is sound navigation and ranging, which is in the ultrasonic range. And answer for part B is radar, radio detection and ranging, that is used for detecting the objects in air, that is or in space. Question number 14. Deduce the dimensional formula of Boltzmann constant and mechanical equivalent of heat. You have to recall Boltzmann constant. Maybe in the subsequent chapters you will learn about Boltzmann constant. That is a constant for relationship between heat and temperature. It is given by Boltzmann constant K is equal to heat over temperature. Heat is ml square T to the power of minus 2 divided by K. K is in Kelvin. K is in Kelvin, this which itself is a basic unit. Therefore, it is equal to ml square T to the power of minus 2 into K to the power of minus 1. Mechanical equivalent of heat in joules. That is work over heat. That is equal to L square T to the power of minus 2 divided by heat is ml square T to the power of minus 2. So it all the m gets cancelled, numerator in denominator. L square also in numerator and denominator gets cancelled. T to the power of minus 2 in numerator and denominator gets cancelled. Therefore, the dimensions of mechanical equivalent of heat joules is m to the power of 0, L to the power of 0 and T to the power of 0. This question you can skip it for the time being and you can revive it after learning the chapter on heat. Next question. Question number 15. Give examples of dimensional constants and dimensionless constants. Answer. Dimensional constants are gravitational constant, Planck's constant, etc., etc. Dimensionless constants are pi and e, that is exponential function. Trigonometric functions are also dimensional constants. Question number 16. The Vernier scale of a traveling microscope has 50 divisions which coincide with 49 main scale divisions. If each main scale division is 0.5 mm, calculate the minimum inaccuracy in the measurement of distance. Answer. Minimum inaccuracy is equal to Vernier constant. That is, Vernier constant is minimum inaccuracy. That is given by 1 MSD minus 1 VSD. That is equal to 1 MSD minus 49 over 50 MSDs. That is given in the question. Therefore, simplifying, we get 1 over 50 into 0.5 mm. That is, if you simplify 1 minus 49 over 50, we will get 1 over 50 into 0.5 mm. That is equal to 0.01 mm. Next question. If the unit of force is 100 newtons, unit of length is 10 meters, and unit of time is 100 seconds, what is the unit of mass in this system of unit? Please note, unit of force, length, and time is given. So we have to substitute force in terms of length and time and mass. Therefore, we know F is equal to ma, that is F force is equal to mass into acceleration. That is equal to dimensionally F is equal to m into L2e to the power of minus 2. So rearranging, we get m is equal to F over L into t to the power of minus 2. Therefore, F is 100 newtons, length is 10 meters, and t is 100 seconds. That is equal to 10 to the power of 5 kgs. Next question. State the principle of homogeneity. Test the dimensional homogeneity of equations. S is equal to ut plus half at square, and second equation is Sn is equal to u plus a by 2 into 2n minus 1. So let us state the principle of homogeneity. The principle of homogeneity states that dimensions of each term on both sides of the equation must be same. That is, if you consider equation 1, the dimensions of S should be is equal to dimension of right hand side. That is the principle. So let us take this one. S is equal to ut plus half at square. Therefore, dimensions of LHS left hand side is only distance, that is S is the distance and it has only length. Therefore, S dimensions of S is equal to 0 mass, length L1, L to the power of 1 and 0 time. Therefore, M to the power of 0, L to the power of 1 and T to the power of 0. Therefore, dimensions of right hand side we will take. So, dimensions of ut is u is the velocity and t is the time. Therefore, velocity is Lt to the power of minus 1. That is, distance over time is Lt to the power of minus 1 into t is capital T plus the second term is at square. So, a acceleration is distance over time by time. That is distance over time square. That is, a is m is 0, L to the power of 1 and t to the power of minus 2 into t square. T square is t into t. T square we have to put it. Therefore, simplifying, so the first term is L, t and t to the power of minus 1 get cancelled. So dimension of ut is L and dimension of at square is m is 0, L is 1 and t to the power of minus 2 gets cancelled with t square. Therefore, L plus L, that is L only. Therefore, the dimensions of right hand side is m to the power of 0, L to the power of 1 and t to the power of 0. Therefore, left hand side is equal to dimensions of LHS is equal to dimensions of right hand side. Therefore, the equation is dimensionally homogeneous. Second question. Sn is equal to u plus a by 2 into 2n minus 1. It is the given equation where Sn is the distance traveled in nth second. So, n has the dimensions of time t. And second, that is Sn minus 1. So writing the equation, Sn is equal to given equation, Sn is equal to u plus a by 2. 1 by 2 does not have dimension. We have to write the dimensions of acceleration a. A is Lt to the power of minus 2 within big bracket into 2n minus 1. So 2n has a dimensions of t, that is time only, n. N is time, nth second, time, minus 1 has no dimension. Therefore, Sn is equal to u plus Lt to the power of minus 2 into t. U is velocity, therefore its dimensions are L into t to the power of minus 1. The first term is Lt to the power of minus 1 plus Lt to the power of minus 2 into t. Simplifying, we get left hand side is Lt to the power of minus 1 is equal to Lt to the power of minus 1. That is distance travel per revolution or per second. So hence left hand side is equal to right hand side. Hence this is dimensionally correct. Next question, question number 19. Describe the principle and use of sonar and radar. Sonar stands for sound navigation and ranging. Sonar uses ultrasound waves. Sonars are used by underwater, please note underwater submarines for remote sensing, navigation for communication purposes. The military uses sonar for tracking enemy ships or destroy underwater mines. Please note underwater mines. Sonar has also research, industrial and medicinal applications. Whereas radar stands for radio detection and ranging. Radar uses radio waves, whereas sonar used ultrasound waves and radar uses radio waves. That is the main difference between the two. Radar has military applications used for weapon control, missile guidance, aircraft navigation, and air traffic controlling. Radars are used in highways also to check the overspeeding of vehicles. They are used in space to detect satellites and motion of other celestial bodies and to check for weather conditions. So, both sonar and radar are used for navigation and detection of different properties and attributes of objects. The waves are emitted. The basic principle is the waves are emitted from a source towards the object. They are reflected back from the object backwards towards the source and are detected by detectors kept in the detection units. This way, the range and distances of the objects can be measured. Next question. Give limitations of dimensional analysis. This is also given in our previous videos, that is chapter number 2.8, 2.9 and 2.10. Answer. If dimensions are given, physical quantities may not be unique because the same dimensions may be there for different physical units. Numerical constants have no dimensions and cannot be deduced by methods of dimensions. Method of dimensions cannot be used to derive the relations other than the product of power functions. So it can be used only for product of power functions. For example, if you take S is equal to ut plus half at square or y is equal to a into sine omega t. The methods of dimensions cannot be applied to derive formula consisting of more than three physical quantities. So dimensional analysis can be used only for when there are only three physical quantities. Give the name of next question 21. Question number 21. Give the name of 6 Indian scientists and their discoveries. Answer. J.C. Bose, Jagdish Chandra Bose, Dr. Jagdish Chandra Bose, ultrasound radio wave. Sir C.V. Raman is his contribution is towards scattering of light. M.N. Saha is responsible for thermal ionization. S.N. Bose is for quantum statistics. Homi Jahangir Bhabha is responsible. He is the inventor of cascade process of cosmic radiation. Number 6 is S. Chandrasekhar. He gave the Formula for Chandrasekhar limit structure and evolution of stars. Next we'll take up 3 marks questions. Name the discoveries made by the following scientists: Chadwick, Bohr, Hubble, Newton, Faraday and Maxwell. This is also these discoveries are given in chapter number 1. Discoveries of different scientists. James Chadwick discovered neutron and he belongs to country UK. Neil Bohr discovered quantum model of hydrogen atom. He belongs to Denmark. Edwin Hubble is expanding universe. He belongs to USA. Isaac Newton gave laws of gravitation, laws of motion and reflecting telescope. He belonged to United Kingdom. Michael Faraday gave laws of electromagnetic induction. James Clerk Maxwell gave the electromagnetic wave theory, that is theory of light. Both belong to United Kingdom. Next question, question number 23. Name the scientific principle which the following technology is based: steam engine, laser, aeroplane, rocket propulsion, radio and TV, production of ultra high magnetic field. Please go through my video lecture on chapter number 1, where all the scientific principles and the the respective technology is given in the form of table in my video lecture number 1. Answer we will repeat it for your convenience. Therefore, technology steam engine is scientific principle is laws of thermodynamics. Lasers work on the principle of emission of radiation. Laser means light amplification by stimulated emission and radiation. Aeroplane works on Bernoulli's principle in fluid dynamics. Rocket propulsion is Newton's responsible. He works on Newton's laws of motion. Radio and TV is based on the principles of electromagnetic wave theory. Ultra high magnetic field technology is based on superconductivity scientific principle. Next question, question number 24. Deduce the dimensional formula for the following quantities: gravitational constant, Young's modulus, and third one is coefficient of viscosity. All these three constants and formulae will be studied in the subsequent chapters, that is chapter 3 onwards. Here just because dimensional this is the question on dimensional formula, we are just giving a simple theory. Gravitational constant, we know that the force between two objects of mass m1 and m2 is respectively is proportional to their respective masses and inversely proportional to the distance between the two. That is F is equal to G into m1 m2 divided by r square. Rearranging, G is equal to r square divided by F into r square divided by m1 m2. This is given here. G is equal to F into r square divided by m1 m2. That is writing dimensional equation, G is equal to ml t to the power of minus 2. Dimensions of force are m into L into t to the power of minus 2 into r is L. So L square divided by m square. Therefore, m to the power of minus 1 L cube into t to the power of minus 2. Young's modulus. Second part is Young's modulus. Young's modulus states that within elastic limit, the ratio of longitudinal stress to the longitudinal strain is called Young's modulus of elasticity of a material. Therefore, this is Young's modulus is the ratio of longitudinal stress to longitudinal strain. But stress is force per unit area, that is written in the numerator, divided by longitudinal stress is change in length over original length. Therefore, that F by unit area is force per pi r square into change in length is delta L divided by original length is L. So, rearranging, we get force per unit area into original length by delta L, change in length, because it gets reversed when it goes to the numerator. So, force is m into Lt to the power of minus 2, that is using the formula mass into acceleration, divided by r square is L square, pi is dimensionless. Therefore, L and L gets cancelled. It becomes m into Lt to the power of L to the m into L to the power minus 1. L square in the denominator, L in the numerator. One L gets cancelled and the denominator L moves to the numerator. Therefore, it is simplified as capital M into L to the power of minus 1 into T to the power of minus 2 within big bracket. Third part is coefficient of viscosity. Coefficient of viscosity is given by eta is equal to force per area into velocity gradient. Velocity gradient is velocity divided by the length. So, force is m into L into T to the power of minus 2. That is using the formula mass into acceleration, divided by area is dimensions of area is L square. Velocity gradient is velocity over the velocity length, that is equal to L into T to the power of minus 1 divided by L, that is equal to mL to the power of minus 1 T to the power of minus 1. Those are the dimensions of coefficient of viscosity. Next question. Question number 25. Describe the parallax method for determination of distance of a nearby star from the Earth. So, this is given in section 2.2 of your chapter in the under the heading measurement of distance. Parallax method is used to measure large distances such as distance between planets, stars. So, for large distances, we use parallax method. Parallax is an apparent shift in position of an object with respect to another when we shift our eyes sidewise. This is also explained in detail. Please see the figure on the right hand side. So, S is a distant star and AB lie on the Earth. So, A and B are the two different positions separated by a distance small b. Capital D is the distance between star and the Earth, and parallaxic angle is theta. It is shown in the figure. Where S is the planet, A and B are two positions of observations. B is the base. So, angle ASB is equals theta is called the parallax angle or parallaxic angle. As the planet is very far away, the ratio B by D is less than 1, far less than 1. Therefore, theta is very small. And we can write AB as an arc of a circle of length B of a circle with center at S. Therefore, distance D is given as the radius AS is equal to BS. That is AS is equal to BS because of the large distance D. So, AB will be equal to B equals D theta. That is tan theta is approximately equal to theta. Therefore, D equals B by theta. We know B, and if we know the parallaxic angle, we can calculate the distance of the star. Next question. Question number 26. Define the following units: light year, parsec, and astronomical unit. Light year is the distance that light travels with velocity of 3 into 10 to the power of 8 meters per second 1 year. Please note, light year is the distance, that is the time, that is the distance, the time taken traveled by light in 1 year at the rate of 3 into 10 to the power of 8 meters per second. Light year is the distance that light travels with velocity of 3 into 10 to the power of 8 meters per second in 1 year. 1 light year is equal to 9.46 into 10 to the power of 15 meters. This you have to remember, this value. It will help you in solving problems. Parsec is the distance at which average radius of Earth's orbit subtends at an angle of 1 arc second. 1 parsec is equal to 3.08 into 10 to the power of 16 meters. Astronomical unit. Astronomical unit AU, represented by AU, is the average distance of the Sun from the Earth. So, astronomical unit, average distance of Sun from the Earth. 1 astronomical unit, 1 AU equals 1.496 into 10 to the power of 11 meters. This value you have to remember. Next question. Describe a method for measuring the molecular size of oleic acid. The size of molecule is very small, ranging from 10 to the power of minus 8 to 10 to the power of minus 10. A simple method for estimating the molecular size of oleic acid is described below. This description is also given in section 2.1, 2.2 of the chapter number 2. Oleic acid is a soapy liquid with a large molecular size of order of 10 to the power of minus 9 meters. We dissolve 1 cubic centimeter of oleic acid in alcohol to make a solution of 20 centimeter cube. Then we take 1 centimeter cube of this solution and dilute it in 20 centimeter cube using alcohol. So the concentration of solution is equal to 1 over 20 into 20 centimeter cube of oleic acid per centimeter cube of solution. Next, we lightly sprinkle some lycopodium powder on the surface of water in a large trough, and we put 1 drop of solution in the water. The oleic acid drop spreads into a thin and large, roughly circular film of molecular thickness on water surface. Then we quickly measure the diameter of the thin film to get its area A. Suppose we have dropped n drops of water initially, we determine the approximate volume of each drop as V centimeter cube. Therefore, volume of n drops of solution is equal to n into V centimeter cube. Amount of oleic acid in this solution is equal to n into V into 1 over 20 into 20 centimeter cube. This solution of oleic acid spreads very fast on the surface of water and forms a very thin layer of thickness D. If this spreads to form a film of area A centimeter square, then thickness of the film T will be equal to volume of the film divided by area of the film, that is equal to n into V divided by 20 into 20 into A centimeters. If we assume the film has monomolecular thickness, then this becomes the size or diameter of the molecule of the oleic acid. That is the answer. Next question. We will take up some questions of requiring long answers. Distinguish between terms precision and accuracy of a measurement. Please go through the video, my video 2.6, 2.7. The accuracy of a measurement is the measure of how close the measured value is to the true value. Precision is the degree of exactness. It tells us to what resolution or limit the quantity is measured. Example, suppose the true value of a certain length is near 3.678 centimeter. In one experiment using a measuring instrument of resolution 0.1, the measured value is 3.5. While in another experiment, it say whose resolution is 0.01, we get the reading as 3.38. So which is the correct value? So correct value, the first measurement has more accuracy because 3.5 is closer to 3.678. So this is more accurate, but less precision, but it does not give information of the next digit. While the second instrument is less accurate because 3.38 is less than 3.5, which is very far away from 3.678. But it is more precision because it gives two digits after the decimal point. Thus, every measurement is approximate due to errors in measurement. Next question, question number 29. Explain absolute error, mean absolute error, relative error, percentage error, and random error. Absolute error in the measurement of a physical quantity is the magnitude of the difference between the true value and the measure value of the quantity. So absolute error is the measurement of a physical quantity is the difference between the true value and the measured value. Suppose the values obtained in several measurements are A1, A2, A3, etc. up to AN. Therefore, the average value will be equal to A1 plus A2 plus A3, etc., etc. up to AN divided by N. Let it be equation 1. Therefore, delta A1 is equal to A1 into A1 minus A mean, that comma delta A2 is equal to A2 minus A mean N, and delta AN is equal to A minus A mean. Therefore, mean absolute error, it is the arithmetic. So, arithmetic mean of the magnitudes of absolute errors in all measured quantity. It is represented by delta A. So mean absolute is delta A, and it is defined as delta A mean is equal to modulus. Please note the difference. Here we are taking magnitude, mod of delta A1 plus mod of delta A2 plus etc. into mod of AN divided by N. This is the mean absolute error. Relative error or fractional error. The ratio of mean absolute error to mean value of the observation is called the relative error. It is given by the ratio delta A mean divided by A mean. That is, A mean is obtained in equation 1 and delta A mean is equation we obtained by using the formula in equation 2. Next part is percentage error. Percent representation of relative error is called percentage. That is, we have to multiply it. Percentage error del A is equal to delta A mean divided by delta A mean into 100. That is relative error into 100%. Random error. Errors which occur irregularly, hence are random with respect to sign and size, are called random errors. These errors occur due to unpredictable fluctuation in experimental conditions and personal errors. Next question. Name 4 basic forces in nature. Write a brief note of each, hence compare their strengths and ranges. This is from chapter number 1. So where we have already defined four basic or fundamental forces in nature. These forces are gravitational force, weak nuclear force, electromagnetic force, and strong nuclear force. Their ranges, gravitational force is the weakest of all the force, and its relative strength is 10 to the power of minus 39. Weak nuclear force is second weaker, 10 to the power of minus 13, and electromagnetic force is 10 to the power of minus 2. Strong nuclear force is very one. It is strongest, and their ranges is gravitational force is infinite, and weak nuclear force is very short, and electromagnetic force is also infinite, and strong nuclear force is short. So their nuclear sizes are also given. So with this, we come to the end of this lecture, and next lecture will be on units and measurements continuation, where we will answer all the multiple choice questions including PYQs. Thank you and goodbye.